especially in 12.1, we looked and we saw sometimes when we had limits coming from the left, coming from the right, and coming out with two different values. What did that mean for the limit? Failed to exist, did not exist. So, it's something that we talk about one-sided limits. A one-sided limit, the limit of f of x as x approaches, and you have that notation a plus equals L1. We'll say that this is just right. This is the limit of f of x, or f of x equals L1 as x is approaching a, and again that plus meaning from the right. Likewise, the limit of f of x as x approaches, and it has an a to the minus. I limit as I'm approaching a from the left. I'll call that L2. So what did we learn about this L1, L2 stuff if I want to find the limit as f of x approaches a? What has to happen to my L1 and L2?
Increasing.
Can they be different? Can they be the same? Meaning what? They have to be the exact same number, right? I can't have a limit approaching one from one side, one from the left side, one from the right side, and coming up with different values. They have to approach the same number. So my L1 and L2 have to be the same. So when we have stuff like this, we have three different limits here. Limit of the absolute value of 2x over x as x approaches 0 from the right, left, and just x approaching 0. This is a graph of this is what this graph looks like. That looks like the v moves. This is actually the value of 2x over x. So for this first one, the limit of f of x as x approaches 0 from the right. What do we get? So right, we're coming from the right, so that means we're using this side over here. As it gets closer and closer to 0, it looks like it's approaching the same constant, and it's going to have a value of 2. So the limit of f of x as x approaches 0 from the left, we're now down here, right? Coming from the left, as I get closer and closer to 0, I have a value of negative 2. What's that? So then, what is my limit of f of x as x approaches 0? It does not exist because, again, as we said before, as it approaches a number from the left and the right, it has to be that exact same one. If I said the unique number, can only be one. Right? Here we have the limit of f of x as x approaches 0 from the right. So which graph are we looking at? Straight line or the curved line?
Straight.
Absolutely, because our 0 is coming from the right, so we're using that straight diagonal line. As it gets closer and closer to x equals 0, it looks like it has a value of negative. 0 from the left, where are we now? We're on the other graph, right? Curved graph, as I get closer and closer to x equals 0, it looks like I have a value of 4. So then what is my limit as x approaches 0. Absolutely. Since 4 and negative 4 are not the same, no limit exists. What about the limit of f of x as x approaches negative 2? Well, where's my negative 2? Over here, right? So, as my graph from the left and the right get closer to negative 2, it looks like I have a y value of. Absolutely. Because we got the same value, right, coming from the left or from the right. They're both approaching on that exact same location. What about the limit of f of x as x approaches 4? Yeah. So here's my 4, right? So as it gets closer to 4, looks like it's approaching. Absolutely. Right. That's all a limit is. As I get closer to that value, what do I expect my f of x to equal? Here we have the limit of f of x as x approaches 0 from the right. Raphael? Or here's my x equals 0, right? So as my graph gets closer and closer, what, from the right, my bad, from the right, what y value is it approaching? 0. Absolutely. So I have the value 0. Brooke, what about from the left? Again, as it's getting closer to x equals 0. Sophie, the limit of f of x as x approaches 0?
0.
Why?
That's the y value.
Because both my left and right have that exact same value of 0. Limit of f of x as x approaches 1 from the right, Alexander. Sorry? As x approaches 1 from the right. So as I get closer to the value of x equaling 1, and from the left, 3, 7, still 2. So from the left or from the right, exactly. It looks like I'm approaching the value of y equaling 2, right? I'm not concerned at all with the value there. Just as it gets closer and closer, what is it equal to? Gives you 9? So what is the limit as x approaches 1? 2. Since the right-handed, coming from the right, coming from the left, my right-handed and left-handed limits are the same number, approaching the same number, my limit's going to be the same. So, what is f of 1 though? Absolutely. So here you can see the value at that point is not always going to be your limit. Don't confuse the two as saying, I'm going to stick in x equals 1 or whatever have you to find out what I get, and that's my limit. No, that's not the case. The limit is, as I approach, what value does it look like? Does it appear to me when I have it? Right?
How do you make the limit?
Hey, Johnny, gets me?
Yeah, how do you well, okay, so when x equals 1, that's what we got.
That's right. We can see this parabola. All the points are defined except for at x equals 1. And it tells you, as Adrian said, when x equals 1, that dot right there tells me I have a value of 1. That has nothing at all to do with the limit, though. So here we have the limit of f of x as x approaches negative 1 from the right. Abby?
Sweet.
Yeah. Let's just stick with the original, Abby.
Oh, there's an okay, so it's negative 1 from the right.
So which graph am I looking at? Which of these three? If I'm looking at negative 1 from the right. Find negative 1 and then look right to the right.
Well,
What's,
you could use like.
no, what's one closest to negative 1 on the right? Dang, absolutely. Here's my negative 1, so we choose the one immediately to the right of it. Right? So as my x, as my graph gets closer and closer to that negative 1, what value am I approaching? And Allie? So now you can speak. So as x approaches negative 1 from the left, which graph am I looking at?
The
This one? Absolutely. So what value do we get?
negative.
Absolutely. So Francine, what is my limit of f of x as x approaches negative 1? What did Michael say in the beginning of the class? Has to be a unique number. Are these unique number? Is this a unique number? 8 and 1.
No.
Therefore, I have no limit there. Habib, as x approaches 2 from the right,
It'll be negative 2.
absolutely, because we're using this right down here. So we get that negative 2 coming from the right, Galena. Excuse me, from the left. As we approach 2. So which graph are we using? This one? Again, find where x equals 2, right, over here, Galena. And we look immediately to the left, which is going to be which one? This guy. So as I get closer and closer to the value of x equals 2, I have a value of, so we find what is my limit as x approaches 2? Absolutely. Yes?
Galena answered, but why wouldn't that be negative 2? Because that's my favorite one.
That's above the x-axis, right? Positive. Right? Any other questions? One more here. Make sure that we have this portion. So the limit of f of x as x approaches negative 2 from the right. Listen. I'm sorry. So coming from the right, approaching negative 2, what value do I have?
1.
Absolutely. And then coming from the left, Coco. And Iman. So what do I have for the limit of f of x as x approaches negative 2? I 1. Can you help out? Absolutely. Since they're both 1, coming from the left and coming from the right, if they are that exact same number, that is my limit. If they're not that same number, there is no limit. If they are the same number, that's my limit. So, again, if you're hashing as far as finding those limits, it's all about one-sided limits. If the two one-sided limits, the right and left are the same, have a limit. Questions? A very common limit that we use, in particular in calculus, is called the difference quotient. We get a nice little formula for that one. The limit of f of x plus h minus f of x all over h as h goes to 0. You'll see this quite a bit, especially if you take calculus. This does not mean you can disregard this if you're not taking calculus, right? So, but this is a very good examples dealing with difference quotients as far as their limits. But again, you use this exhaustively if you go into calculus. How this stuff works? Well, let's take a look. Here we want to find the difference quotient for the function given by f of x equals 2x squared plus 1, while x equals 2. So, it's our difference quotient we wanted to find. We need to know f of x plus h, f of x, and h. Well, h is just h. And in this case, we were letting x equal 2. So we're really looking for let's do the tough one first, f of 2. How am I going to find that? How do I find f of 2 plus h? Do I do it any differently? No. Just like I did f of 2. Wherever I saw an x, I'm going to, instead of placing a 2, I'm going to put what? 2 plus h. What is 2 plus h quantity squared? Don't forget that 2 plus h squared is what? Don't just square your first term and square your last term. Then you're forgetting that outer and the inner term. Foil it out. Double distribution. So what do we get? Okay. So this gave us our f of x plus h, or excuse me, f of 2 plus h, right? So we have f of 2 plus h. We have our f of 2. So now we can go ahead and do that difference quotient, right? The limit of f of x plus h minus f of x all over h as h goes to 0. So my f of 2 plus h minus what? Minus my f of 2 all over h. What happens? Now we have the limit of 8h plus 2h squared over h as h goes to 0. Factor out the h. That's the reason why we factor out the h, folks. Right. So now I'm left with what? The limit of 8 plus 2h as h goes to 0. So what do we do now? Direct substitution. Let h equal 0, giving me what? So all that work and we come up with just 8. So here we have found the difference quotient at x equals 2 for this function is just 8. The second part of this problem asks us to find the difference quotient for any x. And we did it for x equals 2. So to find the difference quotient for any x, I'm not looking at 2 plus h, I'm not looking at x equals 2, I'm looking at x plus h and x. So I need to know what f of x is. Sure enough, we know what it is, 2x squared plus 1. But I also need f of x plus h. How do I determine that? Is it any different than what I did here? Okay, so wherever I see an x, I'm going to replace it with
X plus H.
x plus h. So 2 times x squared becomes 2 times x plus h squared plus 1, right? Roll it out. Absolutely. You get that x squared plus 2xh plus h squared plus 1. I have my f of x plus h now. There's no like terms to collect. So now what matters is the limit as h goes to 0 of my f of x plus h minus what? Minus my f of x. F of x was all of it over h. Now what? Did anything cancel?
Yeah, I mean, you couldn't.
I'm subtracting off 2x squared. I have a positive 2x squared. I'm subtracting off a 1. All that cancels out. I'm sorry?
What, a factor out an H from the top?
All right, factor out an h. Divide out our common factor, and I'm left with the limit of 4x plus 2h as h goes to 0. So what do we do, Michael? Absolutely. Use our direct substitution, let h equal 0, giving us. So this is a difference quotient for any x. In the first part, we did it for x equaling to what? 2. So if I already knew that, this equation here, and I just substitute in x equals 2, 4 times 2 is, which is exactly what we got for the first one. All right? Questions? Here we want to find the difference quotient at x equals 1 for this function, and at the same time we want to find the difference quotient for any x. How should we do this? Any differently? Same way?
What's the shorter in which we do that?
That's what Veep said. All this work we did up here, did we need to do any of this at all? Not at all. Because it already asked us to find it for any x. Once we had that formula, for x, all we had to do is say, okay, that's just 4 times 2. So as we said, let's just go straight to finding the difference quotient for any x. Now we really don't need any space for this part, do we? So I'm going to show my work up here. So again, we're working this problem right now. We're going to come back and work the first part. So f of x plus h, what do we do? Absolutely. So my x plus h quantity squared be something like that. Not complicated, but a lot of writing. So, do I have any common like terms? Any like terms left? No. This is all my f of x plus h. Do I know what f of x is? Absolutely. So we can go immediately to our limit. Minus what?
Your f of x.
Yep. What's that gonna be?
I'm just saying. Very long.
But not complicated.
Uh,
Absolutely. The difference quotients, these problems can be a little bit lengthy. But all you really, hopefully this is the most complicated thing is as far as what we'll find out. Hopefully that's not complicated. So what cancels?
x squared.
So what are we left with? We're left with some terms that all have what in them?
8.
So immediately we can say, hey, let's just pull out the h's. Divide out the h's, and now I do my direct substitution, giving me so this is the difference quotient for any x. But we still didn't do the first part. So what do I need to do for that first part?
7-1.
Right there.
Plug out the h.
And I put a 1 in.
It was 3h.
Absolutely. As I said, in that first one it says, hey, we want to find the difference quotient at x equals 1. So when x equals 1, 2 plus 3. That's definitely a lot easier to do this than it is we did in the last problem, right? We just solved the first part. It's just 5. Instead of doing all this stuff, all we had to do is substitute it in for my NEX equation.
So for the second one, the difference between quotient, is the answer to that at 2x plus 3? Okay, sorry.
Absolutely. For NEX, the difference quotient here would be that 2x plus 3, and for that first part when x equals 1, it would just be the answer of 5. All right, just one more. What do we do here? That's what we suggested last time. Go ahead and start off, since it's asking us for the NEX, evaluate the NEX first, right? So, yes, no?
Oh,
Distribute our 3. Distributed the negative up here. Minus x minus h. Right. And now when we do the what are we subtracting off?
the
So minus 3x squared and what else?
Minus x.
Minus x. So These guys are gone, and I'm left with right? Absolutely. You got that H. So we're left with 6x plus 3h minus 1 as h goes to 0. Direct substitution gives us
6x minus 1.
6x minus 1 for our any x. And then it said we also wanted in the very first step to find when x equals 2. So when x equals 2, I'm sorry? The difference quotient. Again, hopefully that wasn't complicated. It may be a little bit labor intensive. But other than that, we're using a couple things here. We're using, in particular, we're always going to be using that divide out and then simplify.